My name is Junhong Liang, and I'm an associate professor in the Department of Oceanography and Coastal Sciences. And my student and I develop, improve, and apply different types of computer models to study the motion of water and dissolved and particulate materials in the ocean. And in today's talk, I'm going to give an example, which is a study of microplastics in the ocean. And the plastics are not only composed of water and fish. There's also a lot of pollutants that we don't want, and one of them is microplastics. And these are two images of the plastic ships in the ocean. The left images, the left figures here is the plastics that are bigger, or the macroplastics, while the right images here is the microplastics, and this is images from Dr. Mark Banfield's group, and the scale bar here is 100 micron, which is 0.1 millimeter, and microplastics refers to plastic pieces that is 5 millimeter or smaller in their sizes. And microplastics are not only in the ocean, they are also in fish, and the left figure here shows plastics in fish that is from markets in Indonesia, and also the fish and shellfish from markets in California. And also microplastics have been found in table salt, because plastics, they actually could settle, they could change their density. And finally, if they are in fish and salt, you could expect that they're also in our body. I'm sure I have plastics in my body. And this recent study published in 2019, they analyzed 8 human stools, and they found microplastics in all 8 samples. And so they are everywhere. They are also in our body. And of course, we don't know how bad they could be for our health. And of course, if you want to do something to plastics, you need to know where they are and where they go and where they are from. And so we need computer models. And all plastic tracking models use surface current, because our intuition is that plastic flows at the ocean surface like the plastic bottles. But these microplastics, they don't just stay at the ocean surface. And so they actually will feel the effect of subsurface currents. And these are observations in the North Atlantic Gyre of microplastics. And you can see that these plastics comes in different sizes, and they comes at, many of them are very tiny. They are smaller than 10 millimeter in sizes, and they have a rise speed of a few millimeters per second. So they are very tiny. They goes below the surface. And if you've ever taken any physical oceanography class, you know that the subsurface currents, they change its direction and also magnitude with water depth. So the plastics below the ocean surface, they don't follow the surface currents. And recently, we developed computer models and implemented in a plastic tracking model. And this model includes the effect of subsurface currents, and we apply them to study plastics from the rivers from the outlet of the Mississippi River and also the Chaflaya River. And if we don't consider the effect of subsurface currents, then we will only have the left panels. But if we consider the subsurface currents, then when they have a different rising speed, then they will have different trajectories and fates. For example, for the Mississippi River plastics, these plastics that has a rise speed of 0.5 millimeter per second, more of them could reach the coast of Texas than those macroplastics that have infinity buoyant rising speed. But without considering the subsurface current effect, we will not be able to see that. And finally, we include these plastic viewerborne microplastic flux observations by Dr. Mark Banfield. He has a very nice time series of plastics from the Mississippi River, and this river plastic flux has its peak at May to June, which is 1 month after the peak of the river discharge. And then we use this plastic flux, and with those particle simulations in the northern Gulf of Mexico, we could track the trajectories, their lifetime, their propagation speed, and their fate. How many of them make it to the beach, and how many of them make it to the beach of Texas or make it to the beach of Louisiana. And so with such a model, we hopefully could better predict the trajectory and the fate of plastics in the northern Gulf of Mexico. And this is an example of my work. Thank you.